Right, so there's the solutions to that first one from homework 4.5b. So there's my starting point, right? There's my ending point. So I could graph that full cycle, and then I just kind of copied it over as far as I can. I kind of run out of space over here, so I stop, and then I just work my way backwards, ending down there. Oh, that point, ooh, that's a bad point. That point should be up here. Oh man, that point's got to be right there. All right, back up to the midline. Sorry about that. Okay. So that wasn't too bad because I could see a whole bunch of cycles there. But with number 2, I'm not quite so lucky because my frequency is 1/2. Bring down this camera so you can at least see me talking. Because my frequency is 1/2, that means my period's 4 pi, right? 2 pi divided by 1/2 ends up being 4 pi. And that's the only space I've got, right? From negative 2 pi to 2 pi, I've only got a space of 4 pi. So at most, I can see one full cycle, but because of that phase shift sliding me to a point that's not at the end, I can graph that starting point, right? Negative 3 pi over 2 comma 0, right? Because I'm at the maximum. So negative 2 plus 2, back to 0. But when I add 4 pi to that, so I'm adding 8 pi over 2, right? Same denominator because I'm dealing with fractions. That gets me to 5 pi over 2, which is out here. And I can't graph that point. And that's okay. I don't have to graph points that don't exist in the space that I'm given. I just want to graph any points that fit. And so you can see that down here on the bottom, I always find it so helpful to write down the starting point and then the ending point. Then I find the middle by averaging the x values. Find point number 2 and then point number 4, and just plot those as best I can. And so I really only had 4 points to plot. Right, and so I started here, I went down to point 2 and then the midpoint and then point 4. I know I can't get to here, but I know I have to head in that direction. So I just kind of get myself, just kind of follow the same path. I let the wave so far kind of dictate my motion towards 2 pi, but knowing I'm not actually going to make it up to 0, so I just get close, right? Doesn't have to be super close. Do the best you can. Same thing here. I know I have to just kind of continue my way back down. That's a maximum, so I got to turn here, but I'm not going to get back to the midline at negative 2, so because that's going to happen over here at negative 5 pi over 2, or sorry, negative 9 pi over 2. It's not going to make it, and that's okay. I just kind of head back in that direction. Really, what's written down here is the key. If I have that, then I can do the best to graph it, right? Cool. 3, 4, 5, and 6 are not nearly as tricky, I think, because that's more along the lines of what we've done so far. Although we're going, from a graph now and trying to get us to there. So hopefully this all kind of worked out nicely. Because my frequency with number 3 was 1, I don't have to worry about factoring out a b of 1, right? That's not necessary. My midline is 0, so there's no plus 0 at the end there. There's no phase shift for number 4 because of the choice that I made for where my starting point was. And what I want you to see with specifically 4 and 6 is that because the frequency is more than 1, it's a 2 for number 4 and it's a 4 for number 6, because we could find a starting point, find an ending point, and then subtract those x values to find b, and then do 2 pi over omega, to find omega, and then do 2 pi over omega to find b. There are a few choices, right, to find great starting points. I always pick one closest to the origin, okay, where I pick a point that I can see a full cycle. So if I'm seeing sine, I just want to see that full sine cycle. If I'm doing cosine, I want to see the full cosine cycle, if possible. And if I pick a point closest to the origin and I can see the full cycle, then I'm doing the smallest change possible, or I'm not doing some big phase shift way over here or way over here. If I can stick myself near the origin, I'm good to go. But you have the freedom to pick any reasonable starting point that you like. So you might not have picked the same starting point as me, but I bet you would get the same graph if you graphed mine and you graphed yours. And I cannot stress enough if you are looking at a graph and trying to come up with an equation and you think you've got it, graph it and look at it and see if it matches, right? You can do it on Graphing Calculator. You can jump onto Desmos. You just want to kind of mess with the scale, right? You want to zoom trig if you're on your Graphing Calculator, or you want to set up your Desmos graph to look like that. That takes a little bit more. There's no button for zoom trig. On Desmos, once you type in an equation, you get it graphed. The preset setting is 0, 1, 2, 3, 4. It's going to go by integers. We want to go by pi or pi over 2 or pi over 4. And so in the top right-hand corner-ish of Desmos, there's something that looks like a wrench, right? That's your settings button, where you just kind of you mess with the window that you're in by changing your x mins and x max, maybe from -2 pi to 2 pi, and you actually can type in pi and it will change it to pi for you. You don't have to go looking for that button. And maybe you set up your scale or your steps to be something like pi over 2 or pi over 4. These graphs are actually, pi over 4 is the only mark off pi over 2 though. But every tick mark, every grid line is pi over 4. And I did that with a few people last night that were struggling a little bit. And it was really nice to see how if I type in a graph, I can compare it exactly to what I'm looking at. So a lot of choice there in picking what you like. So hopefully you felt like that was okay. I'm gonna stop presenting. But now is the time to ask questions on any of that. And I'm happy to talk through my thought process on number 1, number 2, or anything from 3 to 6. So you tell me. Questions that you think you want to get out there in the open right now, because if not, then onward we go. And whatever we decide to do with the rest of chapter 4, I would like to stop and test our knowledge so far just this semester. We're not going to go all the way back to last semester's trig stuff in chapter 4. We're just going to do trig stuff from this semester, which will probably happen mid of next week sometime. I don't know exactly how long it's going to take us, but my guess is that it's going to take us today and tomorrow to do 4.6. Just because I want to talk registration for next year a little bit, which is going to take me like 15 minutes. And it's a shorter day with homeroom right after this class. And then 4.7 will happen Monday. And so I'm thinking like, using Tuesday and maybe Wednesday to review. And then Thursday, or Wednesday or Thursday to take some sort of assessment on what we've got so far, just so we can get a grade in the grade book before we move on to chapter 5-ish kind of stuff, which we'll definitely want to get to. We might be back in person at that point, and we'll talk more about what that'll look like once we get there. But I'm going to stop for a second. Anything from this homework that you want to get out into the open that you are confused about?
Does one full cycle look any different for cosine and sine?
A cycle of cosine, because cosine starts at the maximum, looks like that. Now, because it repeats, you see very similar types of waves, but where we start with cosine is always at the maximum, okay? Where we start with sine is always on the midline. So what's in red is cosine, what's in blue is sine. And so if you look at the notes that I gave you yesterday, I think I wrote down the difference in where you're looking to start a cycle. For cosine, you pick a maximum, right? Pick a maximum value, and then the end is going to be the next maximum. When you're looking for a starting point for sine, you want to start on the midline and go up. Okay, just make sure you go up, down, and you get yourself back to the midline. That's a really important thing, so I'm glad you asked that question. Yeah, knowing where to look to start a cycle, super, super helpful, because you want to find that C over B, right? You want to find that phase shift. Does that make sense? Yeah. Anything else? Any other questions? Those notes, man, I cannot tell you how helpful I think those are going to be. And when we take this test, it's going to be open note. You do not have to have that stuff memorized, but I want you to know how to use them, okay? And we'll review. I want to give you a chance to practice more of this stuff because I know that it's kind of newer and a little bit tricky. Okay, awesome. All right, let me see. I think we're out of here at 55. So we've got a half hour. So really, I just want to take the next 15 minutes or so to start 4.6, which is the graph of the other 4 remaining trig functions tangent, in terms of the basic trig function, and then the 3 reciprocals, right? Secant, cosecant, and cotangent. But I'm going to take my time here with tangent so that this stuff makes sense. I think if you've had some trig background from last year, then maybe you've seen this graph before. If you don't remember it, that's okay. I want to kind of build it with you. This might be me going a little slower than I need to, but I want you to see why this stuff works so that when we get to the reciprocal ones, that might go a little bit faster tomorrow. But I want to leave that last 15 minutes to talk registration. And if you're a senior, I've got something for you as well. Okay, cool. So find a blank trig graph somewhere. And let's do tangent. I don't know what number we're up to. I don't really care. You can just put it on the next one, whichever one you're at. Let's make every box up and down worth 1, because when we deal with things like tangent, we're starting to get into rational trig functions, right? Because tangent is sine over cosine. Now, I'm not going to put an equal sign right here and say y over x, but that I'm going to put it way over here. That's really my mindset, right? Sine is y, right? Y coordinates on the unit circle. Tangent is x. And I want to make sure that I keep that in mind when I figure out the points. And I'm going to limit the number of points we do because this is going to take me long enough just to do from negative 2 pi to 2 pi. I'll start at 0 and go this way, and then we'll just kind of copy it over like we did the first time around. I could start at negative 2 pi because that's really me starting at 0 and going along this way, but some consistency maybe will help you out a little bit. But the reason why this one's a little bit different than it is for sine and cosine is because we've got fractions, so we're going to actually divide y values and x values. But there are spots along the unit circle where x is 0, which means we're going to be dividing by 0, which we know we can't do. So we're going to run into some spots where this graph stops and we're undefined, right? We're going to have breaks, we're going to have gaps in these graphs. So we'll talk about that when we get there, okay? So go along with me for a little while as we work through this. Let's start at 0. Okay, and so having a unit circle nearby, or at least visualizing it in your head, might come in handy. I don't need more than one color because we're just going to do tangent on this one, and then tomorrow we will knock out secant, cosecant, and cotangent all on separate graphs. Okay, let's start at 0. So if you're at the unit circle and you are at 0 radians, I'm just going to do the y value over the x value at any point that I mentioned. Okay, y at 0 is 0. X at 0 radians is 0. So is 1. So I've got 0 divided by 1, so 0. All right, so tangent of 0 radians is 0. Okay. And I'm going to skip the pi over 6s and the pi over 3s. It might help you get the flow a little bit better, but in terms of saving us a little time, I'm just going to go right to the in-between spots, all the 45 degrees, all of your pi over 4 multiples, and think about what happens there. All right, so open up an angle to pi over 4. X and y are the same, right? Radical 2 over 2. And so if I'm dividing the same numbers, right, anything divided by itself, as long as it's not 0, is just 1. So I've got a point right there. Okay. And then I get to pi over 2. And I stop and I think about what my y's and x's are when I get to that 90 degrees up at the top of the unit circle. And what I see is that y is 1 and x is 0. And I've got 1 over 0, which is undefined. So I know I don't have a point there, but I want to think back to last semester, chapter 2, with these rational functions and what kind of results we expect graphically when we've got a fraction with 0 in the denominator. And maybe you remember, but when we had 0 over 0, we had a hole. right? That ended up being a whole. But this isn't 0 over 0. This is something else over 0. This is 1 over 0. And when we've got 1 over 0, or 5 over 0, or negative 2 over 0, or anything over 0, we get a vertical asymptote. Okay? And because it's 1 over 0, we're actually heading in the positive direction as we approach that. And here's why. Think about going from 45 degrees up to 90, going from pi over 4, like what's happening in this space inside that box? Well, think about what's happening to your y values. Think about what's happening to the top of this fraction, okay? We're going from a 0.707, right, radical 2 over 2, to 1. Our y values are getting bigger, right? From the 0.707 up to 1, my numerator is increasing along the way, okay? So the top of my fraction is getting bigger. Let's think about the bottom. Well, the bottom of my fraction, I'm going from 0.707, and that x value is moving closer and closer and closer and closer and closer to 0, right? Because I'm getting closer and closer to the y-axis. And so what's happening to the bottom of my fraction is it's getting smaller. So the top of my fraction is getting bigger, the bottom of my fraction is getting smaller, and all of my numbers are the same sign because I'm just in the first quadrant, all of my numbers are positive. And so when I'm dividing, right, y over x, and my signs are the same, I'm dealing with positive numbers. So in the first quadrant and the third quadrant, my signs are the same. When I divide, things are going to be positive. When I'm in the second and fourth quadrant, signs are different, so things are going to be negative when I do that. But that trend of a fraction getting bigger on top and smaller on the bottom, and these aren't the actual numbers, but think about it, like 1 over 1 compared to 2 over 1/2, compared to 10 over 1/10, compared to 100 over 0.01, a million over 0.00001, right? When your fractions get bigger on top and smaller on the bottom, we are heading towards positive infinity. Which means as I approach this vertical asymptote, I've got an arrow up at the top there. Okay, and so I'm just going to connect this right now, but I'm not going to connect it with straight lines. It's going to be smooth and curvy, right? So that same kind of upward trend like we did with rational functions, where as I get closer to that asymptote, I'm going to get closer to the arrow right next to it, kind of smooth, just kind of natural. Okay, cool. Now I hop over that asymptote and I see what happens on the other side. Well, when I hop over that asymptote, what's happening is I'm getting myself into the second quadrant, okay? And so at something like 3 pi over 4, I'm going to skip the 2 pi over 3 and the 5 pi over 6. When I'm at that 3 pi over 4, if I'm at a multiple of 45 degrees or multiples of pi over 4, x's and y values are the same. Just have to watch out for my signs, right? So I'm dividing by the same numbers, right? So I know I'm going to get a 1 or a negative 1, but because my signs are different, I've got to point at negative 1 right there. So 3 pi over 4, comma negative 1. When I get to pi, I'm kind of back to y being equal to 0, right? Because I'm at 180 degrees, but I'm dividing by negative 1, but that doesn't change signs because I'm dealing with 0. So at pi, we've got a point at 0. And then when I get to 5 pi over 4, now I'm into the third quadrant where the signs are the same again, and when I divide, same number, same signs, I get a positive 1. So you got those 3 points, which kind of look like they're in a straight line, but they are not, okay? What you're going to see is that if we plotted the points in between, you would see this kind of curvature, and I'll show you what that looks like in a second. But I want to talk about what happens when we get to 3 pi over 2. When I get to the bottom of the unit circle, I'm back to x being equal to 0. It's a negative 1 over 0 at that point. But I'm dividing by 0, and the number on top is not. So I've got that vertical asymptote at that spot. Okay, now I'm still heading up as I move towards that. Why? Because when I'm in the third quadrant, my signs are the same. Okay, and as the numerator gets bigger in the negative direction, and as the denominator gets smaller but still negative, negative divided by negative is still positive. So I still have an arrow up at the top, right, as I move towards that one. And you can kind of see the flow, right, from left to right moving up in that direction. But as I move from right to left, which I know is backwards, but as I stick myself into the second quadrant, which happens between pi over 2 and pi, things are negative. And if I were to move backwards, if I were to go backwards that way, things would be negative in that direction. Go ahead, Evelyn, what's your question?
I was just trying to check my Wi-Fi connection. Sorry about that.
Oh, that's okay. So I've got an arrow down here. As I approach this vertical asymptote from the right, we're negative because we're in the second quadrant. So I've got an arrow down here on the left, an arrow up here on the right, and I just want to connect those. Now, again, if I had plotted a bunch of more points in between here, you would see the connection a little bit better. But here's what it kind of looks like. It kind of looks like x cubed in that we are going to do this smoothly, right? No straight lines, but thinking of that point at pi comma 0 as that flexing point, where I get up to that point a little early, I flex, and then I head off, okay? And you would see that happen if we plotted a whole bunch more points. But just kind of having that x cubed mindset, it's not a perfect graph, but it's something like that, okay? Hopefully we're good up to there. Hop over the vertical asymptote, get myself to 7 pi over 4. Okay, now I'm in the fourth quadrant where signs are different again. You know, you got a negative pi radical 2 over 2 over a positive radical 2 over 2, so I'm going to get a negative 1 at 7 pi over 4. And then when I'm back at 2 pi, really I'm back to 0, so that's going to repeat again. And what you'll see is that we've got an arrow down here again on the other side, and I'll connect them like that, but I kind of run out of space. And what we start to see is this repetitive, you know, almost cubic looking graph that's going to repeat, repeat, repeat. So now I can take these points and copy them over to here, where 0 is the same at negative 2 pi. So it goes 0, 1, asymptote. Negative 1, 0, 1, asymptote. And lo and behold, look at this, nice, negative 1, and there it is, 0, 1, asymptote. And I've got these graphs that just look like almost look like a cubic graph. It's not, but it looks kind of cubic over and over and over again, okay? And there's tangent, okay? It would be really nice if it wasn't broken up like this, where if I, you know, if I had an asymptote and I could put the whole graph, and an asymptote, whole graph, it'd be really nice if we ended on an asymptote at 2 pi, but we don't, we ended at 0. It's kind of the way things work. That's okay. You'll feel better maybe when we get to cotangent, we start flipping stuff upside down. But that's what we've got, okay? And I just want to talk about this graph just for a second to give you some background, give you some info. You know, maybe I flexed a little bit too much here. Maybe it's more like this, a little softer flexing, not quite so exaggerated right there. But I just wanted to ram home the idea that it is not straight at any point. It's going to be curved for sure because we're making trips around the circle, right? But what hopefully you start to see is that the length of time that it takes to complete one of these full cycles is not 2 pi. That from here to here is the period. And then it repeats, 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 right? So sine and cosine took me all the way around the circle to go through that one full cycle. But because tangent is a ratio of those y's and x's, when you go first quadrant through the second, for example, or second to the third, or third to the fourth, or fourth to the first, we see the whole period of tangent happen. Because I look at, okay, same sign in the first quadrant and then different sign in the second. And that covers everything because then I get to the third and I'm back to the same sign again, which is the same as the first. Or you can think about like going from the second, really the second quadrant to the fourth, different signs, same signs. So I go from negative results to positive results, and then from the fourth to the first. So negative results to positive results, negative results to positive results. The period for this function, you call it omega, I guess, but your regular period is not 2 pi. Your regular period for tangent, and you'll see with cotangents the same thing, is actually just pi. It only takes me a length of pi to get myself all the way through this whole function, okay? And then I'm gonna mention one other thing that I wanna make sure we talk about for all of these functions. We didn't really explicitly say it for sine and cosine when it comes to domain and range, but that's gonna play a really big role for us when we start to look at like things in 4.7 with inverse trig graphs, and then just kind of trig beyond this for sure. When we talk about the domain and range for a graph like tangent, domain's a little trickier to write down, so I'm going to save that for after. I'm going to do range first. Y values that we see show up, all of them, right? This goes down forever, right? As I approach this vertical asymptote, I've got any negative number you want, it's going to show up. Same thing on the positive side. So my range for this function is all real numbers, right? From negative infinity to infinity. This is repetitive, right? I don't need to write both of these, but all real numbers from negative infinity to infinity. All of them are going to show up, okay? But with x's, that's not true, right? We've got gaps. We've got these asymptotes that break the function apart. But because it goes on forever, I want to make sure that I write down all of those, right? And look at where the asymptotes are. Pi over 2, and then a distance of pi away to 3 pi over 2. And then a distance of pi away to 5 pi over 2. And then a distance of pi away, 7 pi over 2, 9 pi over 2, 11 pi over 2, and negatives too, right? From pi over 2, and then back a length of pi, and then back a length of pi, and then back a length of pi. So starting at pi over 2, if you add pi, you're going to run into another spot that you can't use. Add 2 pi, you're going to run to a spot you can't use. Add 10 pi to it, you're going to run into a spot that you can't use. And what you saw last semester is that sometimes describing the domain by saying the x values that don't work is sometimes easier than saying all the x values that do. And that's the case here again. If you have these asymptotes, it might be easier to just say, okay, here are the x's that don't work, okay? And I could say the set of all x such that, or the set of all theta such that. I should probably stick with theta, but I'm gonna say x for now, doesn't matter. We're gonna say all of the ones that don't work, okay? It starts at pi over 2. Or I can start at negative pi over 2 or negative 3 pi over 2, whatever. I'm going to pick something close to the origin that doesn't work. I'm going to go on the positive side. So I'm going to say, okay, I can't be pi over 2 for sure. But if I add pi to that, or I add 2 pi to that, or I add 3 pi, or 4 pi, or 10 pi, or 100 pi, or 1,000,000 pi, I'm going to run into another spot that doesn't work. Okay, so here's what I'm going to do. I'm going to add something to this, and it's going to be multiples of pi. I'm going to call it n pi, okay? And I'm going to tell you, comma, what n is. N is a member of the set of integers. 1, 2, 3, 4, 10, 1,000,000, whatever, also the negatives. Okay, the symbol for integers, okay? You know how the set of real numbers is that capital R, it's got 2 lines going down? I wish it was a capital I, it's not. It's actually a capital Z with 2 lines. Things like that, okay? And if you want, maybe you put a little note for yourself that that right there is the set of integers. There you go, okay? This is your domain. X cannot be equal to pi over 2 plus n pi, where n is in the integers, any integer you want. Cool, I'm good right there. I want to stop and pause and talk registration for next year, okay? But seniors, I'm going to talk to you first, okay? You don't have to worry about registering for next year. So what I've done, if you check on Canvas, there is a spot for you as well. If you look at today's announcement, seniors, You see kind of third section down there. It says seniors, you can skip what's listed above, which is the math course request form. It's unofficial. If you want, I included a form there for you because I would love to hear what you're thinking about for after graduation and how you're feeling about being a second semester senior. But also, if you need some guidance, if there is something that you think you want to run by me, or like you're like, I have no idea what I'm doing next year. I know you and I collectively don't really know each other all that well, but I've actually done a lot of things in the short time that I've been living this life. I took a year off after high school. I spent 3 months in Germany. I spent 6 weeks in the state of Georgia working for Habitat for Humanity at their international headquarters. I've worked internships, all across the country, different kinds of jobs. I've played college sports. I play semi-pro baseball right now. I've got a lot of life experience. I made a lot of mistakes, done a lot of fun stuff. I have a few regrets, but a lot of great experiences, and I would love to share some of that knowledge with you. So seniors, if you want, you can log off right now. You are good to go. But I'd love for you to fill out that form if you want. It's optional, but if you're interested in sharing with me or hearing some advice, I'd love to share that with you, okay? So seniors, adios. I will see you tomorrow. Nothing you need to do before then. Everybody else, stick around because I want to talk a little bit about the form that's listed above that, okay? It says on today's announcement, go to that, the 21-22 math course request form. Again, this is completely unofficial. This is not registration. That's next Wednesday, okay? And I just kind of want to talk to you about what your options are. So I'm going to share my screen so I can pull up that form and point you in a certain direction so you can start to look at what you might choose for next year. I'll just go right to the form itself, okay? And I want you to scroll down and just look at my screen and look at the pathway for next year, thinking about what your choice might be, okay? I'm gonna try to do this in 10 minutes. I'll move the camera down so you can see the top. Your choice for next year kind of depends on whether or not you're gonna be a junior next year or a senior. If you are a senior, you probably are headed in one of 3 directions, okay? The most challenging class is the one I'll start with. That's Calc BC. Okay, now I know we haven't even had Calc A yet. So it's gonna be kind of tricky for you to make that jump to Calc BC without knowing whether or not you're good at Calc A yet. So you kind of have to use a couple things to help kind of guide you. Number one, do you like this stuff a lot? Do you love math class? Is that one of your favorite classes? And are you maybe headed in a math direction or an engineering direction? Is that something that you want to make a priority for next year? Like that class is probably going to be priority number 1 or number 2 at the least if you want to be successful. If you don't make it a priority, you probably will struggle and it gets a lot harder. Okay, Calc A, you're going to see might be difficult at first, but you see that the concepts are not super challenging and the processes, the strategies that we have aren't crazy. Calc BC is a lot harder than Calc A, okay? But it's going to give you the best background in calculus. If that's something that you may be pursuing, a math degree, an engineering degree, a science degree, they're probably going to make you take at least Calc 1, but probably more like Calc 1 and Calc 2. And when I say Calc 1, what I mean is Calc AB. And when I say Calc 2, I mean basically Calc BC. And I know there's overlap there. It's because that Calc B semester is pretty loaded with a lot of ideas. It's usually the one that is most challenging because it's where things really take a turn and get kind of tough. Mr. Lynch teaches that right now. I expect him to teach that again next year. He knows his stuff really well. He knows how to teach it. Hopefully we're back in person so that learning is a little bit easier. But that's really like, we want one section of that. Okay, Calc BC is really the best of the best coming out of this class. You want to feel like things have been really easy up to this point and that you've enjoyed it because you're going to want to make it a focus, okay? Another option would be Calc AB. both AP classes, but you'd see a repeat of this semester's calculus next fall, which a lot of people really like because it solidifies those introductory ideas that you need to really have, like they got to know them like the back of your hand for Calc B and Calc C, and then Calc 3. Like I took through Calc 4, but I have a math degree. My bachelor's of arts is in mathematics, not even education. I have a math degree. So that's why I had to go as far as I did. You probably don't have to if you're not heading in that direction, but that will take some pressure off you in terms of rigor. It also makes your fall semester a little bit easier because you're seeing stuff again, which is cool. Right now, that's Mrs. Gibson. Not sure if she'll be teaching it again next year because we do have some changes to our course loads. So I'm not sure who's going to be teaching that. Might be Miss Nusman. I don't know. I can only speculate, and that's all it is, speculation. Okay. It's a great choice for those of us that want that AP credit because that weighted GPA, right, goes up. And if you get that 4 or 5 on the Calc AB, maybe that checks off Calc 1 for you when thinking about those general education requirements that you might have if you were headed off towards college after senior year. Also, that's a really great choice for juniors, okay? Now, BC also, juniors for sure, like next year's juniors, great choice if math is your thing and you want to be challenged and you want to really beef up your transcript, because if you're a junior in Calc BC, then your choices for senior year are either AP Stats, and there you go, you've got 2 AP math classes, or if you are basically the best math student in your whole grade, maybe you take Calc 3 senior year. Not offered at this school, but we've had a couple people, Sarah Gates, Ben Norby. You're talking about the best math students in the whole school might go on to take Calc 3. I think we've had 3 students in 5 years take Calc 3. But if you're a junior, you could take AB or BC junior year, and then senior year you take stats. Okay, and that's a really nice choice. Okay, and that's the other option, right? Now that's really seniors only AP Stats, because if you're taking that as a junior, there's nowhere to go senior year. You don't really want to take a year off from calculus and then try to pick it up again, because calculus is very algebra based. It's definitely an algebra based kind of thing where you learn algebraic manipulation of functions and learn about how functions change and what we can do with calculus to learn about them and find things about them. So that's why it's under the seniors only. It's really only a senior choice. But still, it's AP. It's got AP rigor. It's got AP expectations. It's an AP test at the end of the year, which is optional, and that's true for all 3 of those AP classes. You don't have to pay for the $100 for that AP test at the end of the year. That's up to you. But you still get that bump in the weighted GPA either way. The other option for seniors, so if you're a junior right now, next year senior, but maybe you're just not a mathy kind of person, but you've always kind of been good at it, but you know that maybe that's not what you're interested in pursuing. Maybe you take a class like statistical reasoning to lighten your math load, because the rest of your schedule is a lot heavier. Maybe you're taking 3 or 4 AP classes already, and maybe you're headed in more of a humanities, like an English direction or a psychology or theater or music, and maybe math is not super high on your list of things that you're really into, or classes that you worry about having to take a lot of in college, if that's the direction you're heading. Statistical reasoning is great. It's still a great, strong foundation in statistics, which I think is way more useful to the general population than calculus is. I think 100% of the world needs to understand statistics. I think 5% of the world needs to understand calculus. Calculus I think is a little bit more fun and fascinating, but statistics is a little bit more revealing about the nature of numbers, and it's stuff you haven't seen before. So a really great choice for sure. Okay, so those are your 4 choices. If you are super mathy and you want to take 2 math classes next year, awesome, you can do that. Right? That's probably seniors only, right? Probably seniors only I'm talking to, next year's seniors. Okay. The AP stat right now, I think, is Lynch and Sigmund. awesome teachers that definitely love the subject, know it really well, and you'd really enjoy. Stat reasoning, I think, is going to change next year. We don't know who that's going to be because right now I believe that's Mrs. Johnson, and she looks to be retiring. So, but nothing's set in stone. So there's your choices. And of course, I've got other questions here, who are you? What are you in right now? Because this is the same deal for my Algebra 2 classes that I teach. What grade are you going to be in? And then, which class do you think you're headed into? Now, maybe I will change this to checkboxes so that in case maybe you say, you know what, I want to take Calc AB and AP Stat. Maybe you select both. That's okay. And the last question is, how do you feel about that choice? Do you think you've really got a lock on this? I feel confident this is the best choice for me, or do you want some guidance from me as to what might be the best choice for you, right? I would love to hear that so that I can reach out to you guys in case there's something that is still pressing that you're just not sure about, which is why I'm giving this to you a week before registration, because I want to have individual conversation with each one of you if you'd like one. Okay, so there it is, 10:55. I got to it. Any questions about any of those courses that maybe you want answered now? I tried to lay it all out there so that you can make your own choice sometime today. But I would love to talk to you on an individual basis about how you did this year, what's my perspective as to what I think might be best for you. And you're going to hear me ask questions like, well, what do you want to do after graduation? What do you want to do after next year? Are you going off to college or not? What kind of job do you think you might want to be interested in? And the answer of I have no idea is a great one, right? I'm 35. I don't know what I want to do with the rest of my life. So you're 16, 17 years old. You probably don't know what you want to do either, and that's okay. So stick around if you have any questions.